Why use abstract-based classes in Python? Because I am used to the old ways of duck typing in Python, I fail to understand the need for ABC, abstract-based classes. The help is good on how to use them. I tried to read the rationale in the PEP, but it went over my head. If I was looking for a mutable sequence container, I would check for _setItem_, or more likely try to use it, if. I haven't come across a real-life use for the numbers module, which does use ABCs, but that is the closest I have to understanding. Can anyone explain the rationale to me, please?
Short version. ABCs offer a higher level of semantic contract between clients and the implemented classes. Long version. There is a contract between a class and its callers. The class promises to do certain things and have certain properties. There are different levels to the contract. At a very low level, the contract might include the name of a method or its number of parameters. In a statically typed language, that contract would actually be enforced by the compiler. In Python, you can use if for type introspection to confirm that the unknown object meets this expected contract. But there are also higher-level, semantic promises in the contract. For example, if there is a _str_ method, it is expected to return a string representation of the object. It could delete all contents of the object, commit the transaction, and spit a blank page out of the printer. But there is a common understanding of what it should do, described in the Python manual. That's a special case, where the semantic contract is described in the manual. What should the print method do? Should it write the object to a printer or a line to the screen, or something else? It depends. You need to read the comments to understand the full contract here. A piece of client code that simply checks that the print method exists has confirmed part of the contract, that a method call can be made, but not that there is agreement on the higher level semantics of the call. Defining an abstract-based class, ABC, is a way of producing a contract between the class implementers and the callers. It isn't just a list of method names, but a shared understanding of what those methods should do. If you inherit from this ABC, you are promising to follow all the rules described in the comments, including the semantics of the print method. Python's duck typing has many advantages in flexibility over static typing, but it doesn't solve all the problems. ABCs offer an intermediate solution between the freeform of Python and the bondage and discipline of a statically typed language.
At Odd Thinking's answer is not wrong, but I think it misses the real, practical reason Python has ABCs in a world of duck typing. Abstract methods are neat, but in my opinion they don't really fill any use cases not already covered by duck typing. Abstract-based classes' real power lies in the way they allow you to customize the behavior of isInstance and issueClass. _subclassHook_ is basically a friendlier API on top of Python's _InstanceCheck_ and _subclasscheck_ hooks. Adapting built-in constructs to work on custom types is very much part of Python's philosophy. Python's source code is exemplary. Here is how collections.container is defined in the standard library, at time of writing. This definition of _subclassHook_ says that any class with a underscore contains underscore attribute is considered to be a subclass of container, even if it doesn't subclass it directly. So I can write this. In other words, if you implement the right interface, you're a subclass. ABCs provide a formal way to define interfaces in Python, while staying true to the spirit of duck typing. Besides, this works in a way that honors the open-closed principle. Python's object model looks superficially similar to that of a more traditional OO system, by which I mean Java. We got your classes, your objects, your methods, but when you scratch the surface you'll find something far richer and more flexible. Likewise, Python's notion of abstract base classes may be recognizable to a Java developer, but in practice they are intended for a very different purpose. I sometimes find myself writing polymorphic functions that can act on a single item or a collection of items, and I find isInstance_x, collections.iterable, to be much more readable than Hassiter_x, _eater_, or an equivalent try.except block. If you didn't know Python, which of those three would make the intention of the code clearest? That said, I find that I rarely need to write my own ABC, and I typically discover the need for one through refactoring. If I see a polymorphic function making a lot of attribute checks, or lots of functions making the same attribute checks, that smell suggests the existence of an ABC waiting to be extracted. Without getting into the debate over whether Java is a traditional OO system. Addendum: even though an abstract base class can override the behavior of isInstance and issueClass, it still doesn't enter the MRO of the virtual subclass. This is a potential pitfall for clients. Not every object for which isInstance_x, meabc, == true has the methods defined on meabc. Unfortunately, this one of those just don't do that traps, of which Python has relatively few. Avoid defining ABCs with both a _subclass hook_ and non-abstract methods. Moreover, you should make your definition of _subclass hook_ consistent with the set of abstract methods your ABC defines.
A handy feature of ABCs is that if you don't implement all necessary methods and properties, you get an error upon instantiation, rather than an attribute error, potentially much later, when you actually try to use the missing method. Example from this URL. Edit to include Python 3 syntax. Thanks at Pandas Rocks.
It will make determining whether an object supports a given protocol without having to check for presence of all the methods in the protocol or without triggering an exception deep in enemy territory due to non-support much easier.